All right, thank you very much. As we are actually done with the opening prayer, I want us to go to the branch anthem.
There is no other branch of the NSC like Ikeja branch. Is the 32nd branch of the NSC. Is a branch to match. Building a viable engineering culture dedicated to bring out the best and to nurture the best of the best. The second to none is Ikeja branch. The best of the best. The second to none is Ikeja branch. With God on our side, will be no fair and wide where the branch to watch. With wisdom we will lead, and discretion we will build, will be known for certain. Together we will make a great nation, proud innovations and professionalism all around. The best of the best, the second to none is Ikeja branch. The best of the best, the second to none is Ikeja branch.
Thank you, everyone. Really appreciate you. So I will want to give a welcome address now for this technical section. This is actually always happening every month, and sometimes when we have other programs, we have to push it forward. But I want to appreciate it because this program, this technical section is actually there to continue to encourage us and continue to broaden our knowledge on our technical tools, because as an engineer, you need to be very, very sound where you are working, and at the same time, you need to continue to improve yourself, which we call the continuous improvement. So this actually one of the reasons why we actually bring this to our midst, and for us to continue to remind ourselves that we have solutions to provide, and we have people actually looking up to us outside there for the solution that we want to provide. So today we will be having a technical section on the life extension of structures, which is a theoretical model for concrete plus embedded infrastructure, which we have our esteemed facilitator and the guest speaker for the day, Engineer Femi Yusuf, FLSC, which will be taking us through the program. Before I start, I will want to, first of all, appreciate everyone that joined the call for the day. I want to appreciate all our fellows in the house. I want to appreciate all the executive members. And firstly, I will once of all appreciate the chairman of the branch, Engineer Nima Zumuli of NSC. She's the O1 of NSC Ikeja branch, and she is the one that has given us the opportunity to also gather here today. So I want to give the kudos back to you, ma. Thank you very much for the concerns and for your effort to ensure that we always develop ourselves both technically and mentally as well. So I want to appreciate each and every one of us that actually deem it fit to also come around today to come and learn one or two things today. I say thank you very much. I really appreciate each and every one of us. So what are the expectations that we're actually looking up to at the end of this program? As you all know that one of the key highlights for this training or this technical section is talking about the theoretical model for structures and life extension. Also, we'll be looking at the practical approach to rehabilitation and durability improvement, enhancing the performance of aging infrastructure. So these and many more guest speaker is going to actually talk about today. So thank you very much for your attention. We really appreciate it, and every one of us. Once again, thank you and God bless you. So now we begin into safety moment, while I call Engineer Peter Ogunbowale as to take us on the safety moment for the day. Thank you very much.
Thank you very much. Please, can you confirm you can hear me, sir?
Yes, you are audible.
All right, thank you very much. Distinguished leaders of the Nigerian Society of Engineers, our esteemed branch chairman, Engineer Nimot Muili, MSc, FNSC, PMP, elders of the profession on the call, fellows of the Nigerian Society of Engineers, members of the executive committee, distinguished engineers, invited guests, ladies and gentlemen, all protocols duly observed. My name is Engineer Peter Ogunbowale, the chairman for the Resource Portal and Job Desk Committee, and I have the privilege of taking the safety moment for today's section. First, I would like to sincerely appreciate the Technical Secretary and the chairman of the Technical and Professional Development Committee, in the person of Engineer Olubunmi Akimboboye, MNSC, for the opportunity to take this segment. I do not take it for granted, and thank you very much, sir. Distinguished participants on the call, before we proceed, kindly permit me to briefly take us through our online safety and housekeeping guideline. First, kindly ensure that your microphones remains muted at all times, except when you are invited to speak. This helps to minimize background noise and ensure a smooth section. Participants are encouraged to make use of the chat box for questions and contributions. Questions will be addressed during the Q&A segment at the later part of this call. Please note that this section may be recorded strictly for documentation and learning purposes. By remaining on this call, you consent to this recording. Kindly avoid sharing meeting links, screenshots, or section materials outside this platform without proper authorization, in line with professional and data professional standards. In the event of any technical difficulty, please try to rejoin using the same link. The technical team is on standby to provide support where necessary. Beyond platform guidelines, I would also like to emphasize personal safety. If you are joining us while you're on the move, especially if you are driving or operating an equipment in your office, kindly avoid multitasking that may distract you. Your safety is very paramount. If you are in your office or at home, please ensure that you are in a safe and comfortable environment. I will also encourage you to please take short breaks if needed. Stay hydrated and keep bottle of water close. Your well-being is important even during this virtual section. We also encourage all participants to maintain professional conduct throughout the section. Be respectful in your contribution. Avoid posting unrelated messages or promotional content in the chat box. Stay engaged and minimize distraction. I want to say thank you all for your attention and comprehension. I wish you all a safety, productive, and impactful section. Thank you very much. Over to you, the Technical Secretary. Thank you.
Engineer Ogunbowale, you can just carry on.
Oh, okay. I'm sorry.
Okay, sorry, he's speaking now.
Thank you very
Yes, are you
much for
set?
that. Yes, I'm here. Thank you very much, Chairman, the Chairman of NSA Ikeja branch, for the opening remark. Engineer Nimot Muili, FNSC, FNIEE, PMP, the Chairman, NSA Ikeja branch. Please, if your hands are not too busy, please can you use your emoji to welcome our Chairman as you give welcome address. Thank you very much.
Yeah, good afternoon, distinguished engineers, I appreciate everyone present on the call, starting from a very senior engineer who has volunteered himself to give us a session today on something that concerns all of us, longevity of our structures using proven theoretical methods. I acknowledge the presence and appreciate Engineer Gani Ogulabi, which usually will be one of the first, between 1 and 2, is already at our various event. Thank you very much, Engineer Gani Ogulabi. The technical
You are
secretary
welcome.
and the team. Thank you. A pleasure, sir. The technical secretary and the team, thank you very much for bringing this to us. The assistant general secretary is also on the call, and I use him as a point of contact for all the EXCOs that are on the call. To our past chairman, who may be on the call, thank you very much for joining. The young engineers as well. I see the young engineers coordinator on the call. I use her as a point of contact for all the young engineers. RPJ committee chair, a member of the technical secretary, thanks for stepping into support in anchoring this program. And to everybody present on the call, thank you very much. The topic is a very germane one that most times we eventually see collapse, but something gradually will lead to it when they are not maintained or their life are not strategically extended. So we're going to be listening to what Engineer Femi Yusuf will be taking us through on some methodology that he has worked on and have proven to extend the structural life of structural members. And that's not only focused on structural members. Of course, if there are no structural members, every other materials or every other discipline will not have a place to put their various items and activities. So on that note, I implore us to listen attentively and take time to learn, relearn, and acquire new knowledge on this very important topic. Please feel free to share with your other colleagues that are not yet on the call, and let's have a very wonderful and engaging session. Thank you. Engineer McGregor, thank you very much for joining, sir. I cite you. So I yield back to the anchor, and I look forward to a very enlightening session. Thank you.
All right, thank you very much, Chairman. That is actually a very warm welcome. This is actually a very great one. Thank you for always supporting, and I really appreciate you. Thank you very much. So moving forward, we'll be going straight to the program of the day as we take the citation of our guest speaker. We call on Engineer Oluwatoyin Eniojukan, MNLC, the coordinator for the Young Governors Forum, here from NSC Ikeja Branch, to help us in the citation of our guest speaker. Thank you very much.
Thank you very much, my technical secretary, the chairman of the Nigeria Society of Engineers, NSC Ikeja Branch, Engineer Nimot Muili. Thank you. Our guest speaker who is on the call, all the fellows in the house, senior engineers, and also the young engineers, as well as other guests who are on the call. Thank you all for joining. I would be taking the citation of the guest speaker. Engineer Femi Yusuf is a graduate of civil engineering from the Federal University of Technology, Minna, Niger State. He has a Master of Science degree in Construction Project Management from London South Bank University, UK, and a Master of Business Administration from the University of South Wales, UK. He has attended several courses and seminars in Nigeria and overseas to improve his knowledge and exposure to various aspects of material science, civil and structural engineering. His areas of expertise are construction materials such as cement, concrete, and mortar, structural analysis and design, retrofitting of concrete structures, construction management, project management, and business development. He is a counsel for Regulation of Engineering Foreign and Engineering Council UK registered engineer. He is a fellow of the Nigerian Institution of Structural Engineers, FIN Structi, a fellow of the Nigerian Society of Engineers, NSC, and a member of the following professional bodies: the Institution of Civil Engineers, UK, ICE, Project Management Institute USA PMI, Society of Cement and Concrete Researchers Nigeria, SCCRIN. He is a founding member and executive member of the Society of Cement and Concrete Researchers of Nigeria. He has presented several technical papers of cement and concrete research and recently contributed to an international publication on key themes in energy management, a global perspective. He has also had technical presentations of 3D technology at the University of Ibadan International Civil Engineering Conference in 2024. He is the founder and CEO of Lafezat Consultants Limited, where he's supporting business development, the development of sustainable cementitious materials and advancing building structures. He also currently works for Cavendish Nuclear UK as a principal civil structural and architecture engineer, where he has responsibility for managing multidisciplinary team, supervision of engineers and technicians, and also supporting business development and maintaining industry best practice. Please, with a clapping ovation, I want us to please invite our guest speaker, Engineer Femi Yusuf, FNSC, FNI/E, who is the founder and CEO of Lafezat Consultants Limited. Engineer Femi, we sincerely welcome you. I cannot see the clapping emojis from the chat box. Please, I need to see the clapping emojis, everyone. I'm seeing just one. We can do better than that. All right. Thank you very much, Engineer Femi. Over to you, sir.
Thank you very much, the anchor of today's event. I really appreciate this platform and the opportunity to share knowledge with my fellow colleagues and rub minds on a topic that I think we'll all find quite interesting. I appreciate the chairman of the NSE Ikeja branch, the elders, the fellows, the technical secretary, and all other protocols duly observed. So without much ado, I would like to share my screen and start the presentation for this evening. Oh, I need you to allow me to share my screen. It says host disabled participant screen sharing.
You've been allowed, sir.
Okay, thank you. Let me try again. Okay. So please confirm if you can see my screen. Can you see my screen?
Yes, sir.
Okay. So, life extension of structures, a theoretical model for concrete and embedded infrastructure. I'm using an example of an old dock structure that was built in the 1970s. And this came about because the client, a government agency, didn't have enough funds to rebuild the structure. So what they decided to do in a smart way was to approach us in a consultancy mode to say, what can you do to help us keep this structure alive for the next 20-something years? And that required a lot of work. But also there isn't any, what you will call like a standard code of practice for this. So that meant that you have to dig into your knowledge of engineering and also knowledge of material science, and any research that is out there that can be backed and verified, and that's what we did. So I have been introduced, so I won't go much into that. Thank you very much. The main focus will be around durability and rehabilitation. Basically, in Nigeria, you realize that we have a lot of aging infrastructure, and we don't have the capital to build as fast as we may need to replace them. There's also the high cost of replacement. Cement is now 12,000 naira, so we don't know what it will be by the end of this year. So what that means is that whatever capital allocation has been provided may not even be enough for this financial year, not to talk of the previous deficit that we have. So what that means is if we can develop unique solutions, unique methodologies to keep our old infrastructures going, it will really be very helpful. We also need sustainable solutions. That is also something that will help to reduce the cost of building new ones. And I've mentioned the high cost of construction. What I will do to give a structure to this presentation is to discuss the life extension model. I'll also discuss the deterioration mechanism. So before you can extend the life of a structure, you need to know how it deteriorates, how it degrades. Then I'll go into the test methods, the repair methods, and then I'll discuss the application on a case study. The case study is, like I said earlier, is an old dock. A dock is a structure where ships will berth. It has a big name. When you hear a dock, usually when you hear a dock, most people feel like it's something that is so complex. Its structural components consist of piles, pile cap. You have the loading bay, the loading platform where the ships will be tied to, and then it usually has a lot of subways to manage high tides, because sometimes when the tide is high, the pressure on the seawall will be very high. So they have outlets that will go into those subways to reduce the pressure on the wall. And then you also have retaining walls, high containment parapet walls, and then you have a lot of structures, buildings. Of the dock itself. And that's practically it. But the case study was built in the 70s. It has got to the end of its life, but the client doesn't have money to rebuild it. So they're asking for at least another 20 years extension. And one of the things that was done is to identify the defects and also to label the types of defects before you can provide a solution. But one of the key things to think about is that usually we always think as if design at the end of the project design life, the project has to be demolished and rebuilt. But what we're beginning to see is that there is a direct link between engineering, finance, and the environment. Because you as the engineer will say, well, I'm sorry, this structure, it has done well, it has fulfilled its design intent, and it should go. But the people who are paying our salaries and keeping us going say, look, can you think of a way of keeping this structure going? And that is a direct impact and link to how the country and the economy is managed. Also, maintenance provides another avenue for us. There are times that you may not have a project where you need to do it is a new design per se, but you need to find a way to maintain it. So what you then find out is a performance and time concept is a very unique model that you will see playing interfacing. And this is a very unique situation to be in. Engineers usually like designing something from scratch, building it and handing it over and then observing from a distance if the design intents are being achieved or what you've modeled is being achieved, because you've implemented load factors, from previous data, you've applied loads and you've determined the kind of structure is going to be it mechanical, civil, whatever. And what you are doing is just observing what you have designed perform, but this is a different one. Now, for the structure to deteriorate, there are typical things that happen. It's either carbonation is happening within the mix. So typically in a concrete mix, you have cement, water, aggregates, and admixture and sand. And there will be that reaction internally that will be happening. It's a natural reaction. That is why, regardless of how good your concrete mix is, it will have to last a period of time, which is nature. So carbonation is a complex physiochemical change in concrete under long-term influence of carbon dioxide. So you have carbon and chloride aggression, which are the main factors that affects concrete durability. And that is the chemical reaction there. So for the chemists among us, you find out that we are now in a zone where the civil structural engineers are trying to put something together, but they didn't sort of realize that no, we need to understand a bit of chemistry, even though that's not our forte, to be able to move ahead. And the speed of carbonation is determined by different internal and external factors. The important external factors are CO2 concentration, humidity, and air temperature. And like I said earlier, internal factors also play a big role, which is why it is always important that your concrete mix design is good. There's what we call water-cement ratio, and there's what we call air tightness. These things are key. When your water-cement ratio is low and your concrete is dense, the reactions will still take place, but it will not be as high. Now, you have another thing called alkali-silica reaction. Now, for structures that are standing in the air, so once you come out of the subsurface and you are there, their reaction will just be humidity and wind and the rain that happens. But when the structure is below the ground, you have a lot of soil and aggregate, and the types of soil determine the kind of reactions that will take place as well. So these are the deterioration mechanisms. So durability versus structural failure. Now, just like the chairman said earlier, we do see a lot of, it's unfortunate that in Nigeria, the kinds of structures we see mainly are new buildings, which is quite sad, because that means that when you design a building for 50 years standard or more advanced structures for 100 years, you have not even started. But in other climes, they see more of buildings that have reached probably mid-life or towards the end of their life coming down. And this is a factor of being exposed to the factors I spoke about in my previous slide. Corrosion is a key factor. So you can imagine a structure that is constructed near a saline body. Saline body, you are talking about sea, ocean, etc. That has salt, and the salt will react with your concrete cover. So early intervention is critical. So a recap of the key elements I've spoken about is degradation is normal, but it will happen faster depending on the environment. And then poor concrete mix design can also lead to failure or gradual failure. We do have scenarios where concrete scientists or concrete technicians are not involved in some advanced projects, and that could be quite a challenge or a problem. So this takes us to what you will now do to assess a typical structure that has gone to the end of its life, and you are contemplating the possibilities of extending it. So you will do your inspection, you do your testing, you do your analysis, and then you take a decision of how you want to move. In our particular case, this particular example, different types of defects were classified, and this classification moved from like a U to a D. So a U is like an urgent crack. So while you are inspecting, you see a crack and you say, look, if we don't intervene, this one will lead to failure. So if you look at this staircase, they are already holding it with very strong material to pull it together. So that's urgent. And then an E is like the concrete cover is coming, or what you call spalling. And hairline cracks, those could be as a result of settlement. It could be as a result of usage. It could be a result of contraction and expansion, etc. And those are not urgent. And the reason why this was done is for you to be able to determine, okay, repairs that you do immediately, repairs that you do over time. And don't forget that the ultimate goal is to extend the life of the structure, but also you want to keep the structure alive before you determine what action you are going to take. So you do two types of tests. You do the non-destructive test initially, and in that non-destructive test, what you are trying to determine is the current life. So basically, there are 2 or 3 things that will protect the structure. You have your concrete cover, you have the concrete strength itself, and then you have the type of environment the structure is based in. So if the reinforcement based on the type of concrete cover and the strength of concrete has not started degrading, i.e. rusting and losing strength, you may have a challenge. So that's why these types of tests are non-destructive are important. So you have the electromagnetic cover meter survey, which will help you to determine the remaining cover, concrete cover. You have the digital Smith hammer testing. Now, you may also use the manual Smith hammer. It doesn't have to be digital. That will tell you the current concrete strength versus what it was designed for. In its standard RC drawing, it will be stated the concrete strength that the in your notes for that covers the drawing, the standard strength the concrete structures were designed for. Then you have the delamination Harper tap survey. So the delamination is also give you a feel of whether the cover over a surface area is still there or it's started to go off. And then you have the surface resistivity testing. That is to determine the electrical resistivity of water saturated concrete. And this also to tell you how easy is it for water to get into your structure. And then you have the ultrasonic pulse echo testing. This is for scanning subsurface targets in structures. So when you have structures that are buried under the ground, so for example, you have your pile foundation, raft fan, etc., below the surface of the ground. The tests are not limited to this, but I've just picked these ones. Like if you do these ones, at least you should be able to get a good feel. There are a couple more, but with these ones, we are pretty much there to understand what is going on. So when you have done this, you can then begin to plot your strategy, because when you are interfacing with a client that is a bit worried, you want to give a sense of hope. You also want to give a direction. If you say that you're going to wait to a certain point before you start giving a feedback, it's because you see you are managing a high stake client, and you want to be able to tell him, okay, we have an idea of what is going on. This is the status, and this is what we're going to do. Then you move into your intrusive testing. By the time you are getting to your intrusive testing, you already have an idea of how degraded the structure is. So your carbonation test, for example, is a specific test to estimate the depth of carbonation, because maybe you already feel, no, yes, there's carbonation going on because the concrete strength has reduced maybe by 10%, 15%. So of course, carbonation is going, but you want to know the level of carbonation. So we have a code such as BSEN 14630 2006, which is products and systems for protection and repair of concrete structures. Test methods, determination of carbonation depth in hardened concrete by phenolphthalein method, November 2026. Then you have the chloride ingression. Like I mentioned, chloride ingression is very important. You also want to check how much chloride is being absorbed. Then the half cell corrosion assessment. Now, when you do those first two tests in the intrusive test and you realize that the concrete cover has given way, the concrete is not as strong as it was, and you are seeing some reinforcement exposed, and not just being exposed, they look rusty. It's important to then say, okay, that means you may not have the same diameter of reinforcement that was designed for and placed in the concrete. You then do your half cell corrosion assessment to check the steel, if it is steel of this right capacity. So the model, so to give an introduction into the model, so like I said earlier, what makes this a unique space to be in is that there isn't like a code, like you have our Euro Code 2 for design of concrete. We have our EN 1444 for concrete mix design, etc. So you have codes for structural analysis, you have codes for material placement, you have codes but for this space we're in, there isn't a clear-cut code. So you have to pick and mix, use experience, use standards, use theoretical. I'll show you one of the theoretical models we picked up, a very popular, two professors who have done quite a lot of work, and it has proven effective. So the selection criteria of the elements from the viewpoint of corrosion durability is what you do first. So if you follow the way I've been presenting, you will see that we started from sort of a general perspective of the building of the structure. Then we went into saying, okay, how are we going to test? Then you look at, okay, initial, without even doing anything major, just having a physical field, your pneumatic Smith hammer test, your observation and things, then you're going to test. Then you do a risk analysis, because you don't want to go down the route of an expensive repair. once you do your risk analysis, you do your carbonation test, then you can then assess the residual life to say, okay, the client has asked for 20 years. We think from everything we have seen and the analysis, we think what we have left is 10 years. How do we get the additional 10, etc.? Then you determination of the assumed and required minimum service life. Also, what makes this quite a unique situation is when you predict the client will be expecting that, okay, I will not need to go to the government for money for the next 20 years. So you have to be very careful to make sure that you put in some factors of safety. So this may not be very clear. So I will take a few minutes here to try and explain what this chart is all about. And basically, it's from two very good professors, Sazensky and Wolichowski. They've done a lot. They have been referenced in a lot of journals. So I just picked their chart, and you actually reference this chart, and they are very good. What they've done is they look at the carbonation risk and the chloride aggression risk. And at the end of the day, they've developed a formula to predict the reduction of the durability and concrete cover, because those two are very key. And if these steps are followed, there's a high chance you will get a feel of what life is left in the structure. So if a structure was built in 1975, already it has gotten to the end of this year life, but because it was well built, when the initial Smith-Hammer tests were done, there were concrete elements where they were still getting 40 megapascals, 35 megapascals, which is still very, very substantial for a structure that you expected by now to have gotten to the end of its life. So what this helps you to do is to determine the gap. And this is where I said using a methodology that has been used and adopted because there isn't a clear code becomes helpful. So the next slide is talking about going a little bit deeper. So in a typical structure that is fairly okay, all you need to do is to replace the concrete cover, polish. So if the reinforcement is corroded, for example, you scrape it off and apply one of the approved materials and things like that to get it to come back to life. But there are scenarios, you might have situations where there's the concrete element needs more help. So you have things like RT jacketing, you have steel jacketing, FRP warping. I just put this slide there for us to know that you can go as far as necessary, to really strengthen the structure if it is necessary. And you have different examples, column, beams, bridge, shear walls, etc., that you can work on. But in most cases, by the time you are having this scenario, you really have to make a call. Should you bring down the structure or should you just apply these solutions to a few elements? Now, to just throw more light and help us to see what was going on, I've introduced these slides for us to see what was the kind of picture. So the one on my left, where you are seeing the dog bottom with biological growth, if that biological growth is left there over time, there will be a lot of problems. So you will be advised after testing the concrete there, and if there isn't a subway or whatever, you may just advise for that to be removed, cleaned, and allowed to be used as normal. But for the wall to my right, there is a hairline crack going on. So there will be a need to check what is causing that. Is it that the loads have increased on the deck of the dock? Is it that there's pressure? What is causing it? So that will require some investigation. If you look at other things that are going on, you can see what I was talking about. For example, the west wall rusting of the steel stairwell. So now this is a good one. The middle picture is a type of scenario where you can find yourself. Now, if you look at it, the adjoining beams to that steel wall column look fine, but the steel column itself, the connection between the steel column and the beam looks like there is a challenge there and it's already giving way. So in this kind of scenario, you can come back to this slide and look at, okay, because it is steel, what methods can we use can we look at, okay, it's purely steel, so can we look at FRP, for example, to strengthen the column itself, or can we provide a temporary support work, remove that column, bring in a new one, So those are the kind of scenarios you can find yourself. This is just to show live pictures of what's going on. So then the remediation methods, if the concrete has cracked, if there's loss of concrete, if it's a minor defect, what we have done is to enumerate the different remediation proposals, and we have categorized each type of defect such that the repair is uniform across the structure, across the element. For example, if it's just a minor defect, it's to just continue to monitor over time to see if the deterioration will get worse. Look at that last one, steel work or ancillary item deterioration. The solution is to remediate and monitor. And if you remember, I was talking about that steel column earlier, and it says replace or restore components in position and or condition and monitor for future deterioration, failure, or loss, which is exactly what I was saying. In that particular case, you could look at, okay, will a retrofit work, or should you just remove that column and replace? So such scenarios will come up. Others, some we need just minor repair, some we need a deep repair, some we need a shallow repair. And for the concrete types, because we understand concrete very well, we know the way concrete behaves. Concrete failures will typically be cracks, spalling. Spalling is just the concrete cover coming off naturally, and then you then see, instead of using a smooth surface, you just see the honeycomb and you see the concrete hardcore. Reinforcement corrosion is typical. Delamination, failing previous repairs. So repairs have been done, it continues to fail. Foreign objects in concrete, honeycombing, blowholes, reduced concrete cover, etc. And the proposed repair methods are enumerated. The advantage of this is that it reduces the worry about how you are going to implement a repair method, because you have stated it. So all you then do is just to be identifying the types of repairs and listing them. And then there are repair stages. I won't spend too much time here because it depends on how you want to go about it. But basically, there will be an assessment, identification, then you have to decide the type of method, like I discussed in the previous slides. And there are many codes and standards that can help us to do that. We have clause 4 of European standard. We have clause 5 and 6 of the EN 1504. And then EN 1504 up to part 2, EN 1504 to part 7, clause 6, clause 7, and clause 9 of that standard are very detailed and very good. Most of what we are doing are guides. So if you find yourself in this situation and you're an engineer and you're a technical person, the advice is that you even do your own further reading, because you may find out things that will work better for your project. But at least you have a guide on where to go in the first instance. So at the end of most of this and a lot of this work and the methodology and strategy and structure, you are going to get an extended service life. You're also going to get an improved structural performance, because you imagine a dock wall that was designed with maybe 50 megapascals concrete strength. It's resisting on the outer side, it's resisting a sea height of maybe 1.2 meters. That has risen because over time, you expect that to increase and all that. And then internally, it will have the mooring forces of the ship and etc. And then maybe there's a subway on the inner side and things like that. So you have all those forces that have been designed on that wall. And then suddenly, that strength has dropped maybe by 10% to 30 or 35%. That means that the reinforcements in that wall are working a lot harder, and in some cases might even be failing, but you will not know. So some of the cracks we're seeing on those walls could be as a result of the overstress of the detailed and placed reinforcement. So when the improvements are done and the strength is back, then you see the concrete performing better, which could even be part of the solution that you need. Then you have effective project capital utilization. What I mean by this is that there's always a budget each year for capital projects. And most of the times, there is this fight between where to deploy this capital to. If you can improve certain structures, what it means is that you will have there are better chances that other projects will be done. But if there are critical structures like bridges and code that are about to fail, you want to rush to those ones, and projects that should be done each year are left undone, and over time it could become a challenge. So this is actually something that will help us overall being able to deploy these methodologies effectively via a thorough method of assessment, analysis, and a proposed solution. But there were a lot of lessons learned. So it wasn't like a straightforward, like, there were lots of challenges. The first is that the testing methodology is key to achieving expected results. So one of the major issues we had was that when the intrusive tests were completed, sorry, the non-intrusive tests were completed, because of the fear of and the implication of releasing the results, for a long time, the technical team, they were going backwards and forth. And the reason is that if they release the results and they move into intrusive tests, they will come with a proposal. That proposal will be costed. And that costing has an insurance implication, because once the costing is done and the client releases the funds, the client will go home and say, oh, I'll now have my structure for another 20 years. Now, if for any reason, because they will have, I think their defect liability period will be minimum of 5 years. However, for some of these advanced structures, even after those 5 years, you are not really left off the hook like that. If anything happens, you understand, and in this way, it will not be failure. It will just be that the structure didn't last up to the predicted lifespan. You could still be faced with some liability issues. So there was a lot of battle, backwards and forth, after the initial preliminary survey and non-intrusive tests. In fact, I was supposed to sign off the results for the non-intrusive test, and I couldn't sign it off because a lot of key things that were supposed to be there were not there. And I told them, and I said, look, if we sign this off, we still have an opportunity in the intrusive test to adjust. But if you are telling us this is what you have seen, therefore what we have proposed for the intrusive test will be fine, there will be a problem. So that tells you that it's not a straightforward thing, but it can be done. Also, BIM modeling played a fantastic role. And I think this is where technology is very helpful, because all the defects were in the BIM model. In interface with mechanical, electrical, you could see the positioning on all the floors. So I think we had up to 3 or 4 levels below the ground floor. And then some of the cranes. So you could see everything. So it really, really helped. So you could pick a ball, which is the defect, and know the type of defect, the problem, and everything. It played a big role. And it's always important to review preliminary results. Another thing about this methodology proposal is that you will continue to need inspection. Future improvements may be. And I think this is where the consulting team, the proposed contractor, and the client missed the point, because it will never be an end in itself. You will need to develop something, implement it, but then you continue to review. So you needed something like a yearly budget provided, to say, look, you will come back, review where there might be minor tweaks, and hopefully you get to where you want to achieve. The applicability of this are many: bridges, marine structures, buildings, schools, name it. There are many areas where this can be applied, and it's very, very helpful. Even for individual projects, there could be areas in your house, etc., that you feel have become weak over time. It can be assessed, and then you improve on it. There's a lot going on. Yes, we have challenges with our old structure in the country. Maintenance culture, it's not our fault. It's just that the way things are. Funding is a problem. It continues to be a problem, and it's getting worse. The skills gap is there. We don't have as many skilled engineers as we used to have. And to even develop specialist knowledge is not really something that people even want to do, because your forte, your area, your day-to-day area of operation of design, develop drawings, go to site. That it's all the challenge for you to even now spend time developing, you know, a unique skill. I think in some cases people are not motivated and encouraged to do it, except if they are doing like a PhD or research or something. There are opportunities for asset management, for durability, for effective capital utilization. There are opportunities. And when it comes up, you'll be a specialist to be able to manage such periods. So I think I have tried to manage the time as much as I can. I would like to stop here for questions, for contributions, etc. So I'll hand over to the technical secretary. Thank you very much.
All right, thank you very much, sir, for that presentation. That's quite insightful. Please, for those that are distracting the meeting, please, I will appeal to you, please report in mute the mic. And we are now in the Q&A segment. If you have a question, please do show with a raise of hand, and then I'll call you. Thank you very much. Please, the floor is open for questions and answers. And if you are in a noisy environment, you could drop it in the chat box. We'll take it up from there and then ask our invited speaker. All right, we have the branch chairman's hands raised. Let me ask the branch chairman to please speak. Then we'll come back to you, Ademola Balogun. Thank you very much.
Thank you very much, Engineer Ogunbowale. That's Engineer Ademola Balogun, the Public Committee Secretary and Public Committee Publicities Committee Advisor. Please, my apologies. I want the chart you showed on the chart is 1 minute. There was a chart you showed. Is that I think it's on slide 3 also. Sorry, 1 minute. Okay, the model overview.
Yes, this one. Yes.
Is that is a global, I want to confirm that is a globally relevant standard. The reason why I'm asking is, you know, our construction methodology differs, and
Yes.
also concrete strengths. I mean, just typically looking at what we do when we're in school. I mean, for those of us that go to Faculty of Engineering, the construction methodology, the design, you know, they are fair face finished. The concrete strength, they are comparable. So grade 40 of those days, I don't want to say not grade 40 of these days, but is this something, how do you differentiate when you apply it and really evaluate the residual life of the
Yes, a very good question.
And that apply the principle.
Yes. So that was why, like I said, that because there isn't a code, you know, normally if this was concrete design now, there is the Euro code, which we have adopted in Nigeria for concrete mix design and placement. If it was reinforced concrete, that's concrete. If it was reinforced concrete design now, you have EC2, which we are gradually adopting as well. But because this is on extension, not even durability. Durability, you find durability in the Euro code, parts of it, and even in the concrete this thing. But because it's extension, the idea is to look at a methodology that you can adapt and apply with the Euro code that we have. And most of the principles here are discussed in those codes. So you have concrete cover, you have carbonation, all these things are discussed. The only thing this does is that it proposes a theory to estimate the concrete life that is left. So the question you have asked is correct. The only thing this model does is to help to estimate what life is left and how you can extend it. So because when you are engaging the type of clients we have or we had, you have to answer that requirement, which is, I want you to extend the life of my structure for 20 years, and you are going to be paid for it. So you needed to find a model, how you can assess the work you have done to say, okay, with what we have done, we estimate that the structure will last for another 20-something years. And it has to be a calculation, a theory. You have to find something. And that's why this model came to play. I hope that helped to answer the question. Engineer Nimo?
Yes, thank you.
Yes,
It
yes.
does.
So, yes. So it's not
So
a
then
code
that means
itself.
you must get
Yeah.
your, sorry, after you.
Yeah, so it's
After you.
not a code in itself.
Go
It's
ahead,
just,
please.
yeah, so it's just helping us to be able to answer the client's requirements, first of all, and be able to give us a way of communicating to the client. Because it's not the assignment is not qualitative. The assignment didn't say go and repair the defects. The assignment said the structure has gone to the end of its design life. We know, we accept it, but we want you to go and see how you can extend it for another 20 years. So when you are to answer that requirement, you needed something to show to the client to say, okay, we've done A, B, C, D. Based on this theory, we estimate that this structure will go for another number of years. However, that means that each year you must do this, you must do that, you understand? But because they are paying you money for it. So as an engineer, you have to be able to show something. And because this is not something that we have in any of our codes, we have to look for something that has been well researched, well referenced to adopt. So it's that this is the, how do I put it now? This is the sort of like the ingenuity part of it. This is design part of it, of the whole model. Yeah.
All right, thank you. I
Yeah.
think that answered my question.
Okay.
Thanks.
All right, thank you very much, sir. Mr. Engineer Ademola Balogun, you can go ahead and ask a question, sir. Thank you, sir.
Yeah, good evening, everybody. First and foremost, I want to appreciate our presenter, Engineer Yusuf. Thank you so much for the presentation. Now, I want to ask, the work you did was for a dock.
Yeah.
What do you think we can do with regards to the Marina Shore line? You know, if you're coming in from the island into Marina, you are going to CMS. You
Yeah.
know, there are some concrete, I call it sheet pile, what do you call them? That is protecting the land from the sea, from the lagoon.
They are sheet piles, yes. They are sheet piles.
Sheet piles.
Yes.
I'm sure most of them would have given way. You would even see some the concrete has peeled off.
Yes.
You are likely going to see reinforcements being exposed. So how does Lagos as a whole prevent the marina from falling into the lagoon? Because and what advice can we professionals give in that line? Because if we all say it doesn't concern me, you don't know who may be driving around that area that the plane will give in. And so that's my question.
Yes, thank you for this question. It's a fantastic question because it's very similar to this problem. You know, a sheet pile will be exposed to similar problems. I'm trying to find, there was one slide where I spoke, I think, yeah, okay, so these two slides explain your question. So if you look at it, everything here, the sheet pile will experience. because it is in the ground, so it will experience alkali-silica reaction. In fact, all structures will have that, but in different grades. For them, for the sheet pile, it is worse because it's very close to the sea, so water will always get to the pile, and then it will increase the challenges. And then I expect that when the concrete for the sheet pile was being produced and constructed, it wasn't a normal type of cement that was used. So probably a sulfate-resistant cement was used in that concrete. However, it doesn't mean that it is foolproof. In the sulfate-resistant cement, what happens is that there's what is called C2S. It is reduced below a certain percentage to reduce this sulfate attack. But it's likely going to be there. Carbonation and chloride ingress will occur naturally, either internal or external. So to answer your question, I think this slide is what will give a clue to whether, is it this slide? Yeah, okay, this slide first is what will give the first clue to whether there's a problem or not. So by the year it was constructed, and that's one of the powerful things about being an engineer or a concrete scientist. If you follow the natural or the scientific or structured method of how the concrete was constructed, the expected lifespan, and you can estimate when you start having challenges. So for those sheet piles, when were they constructed? What is the environment? What do we expect? So if, for example, those sheet piles were constructed 20 or 30 years ago, they are due for what I will call the initial non-intrusive physical observation and assessment, just to see what is going on. And then this procedure can be followed. Inspection, testing. Testing doesn't have to be detailed testing, nothing. Just when I mean by testing, like the pneumatic test, the observation and things like that will give you a feel of where the concrete is and etc. And then based on those findings, you can then decide if there's an issue or not. But what is also key, one of the things that is, two things that I always say that are important: the design life and the environment. So if the sheet piles are going to maybe halfway of their design life, and the environment is a challenging, aggressive environment like we have, logic says that you will not have the same quality control. You can imagine when those sheet piles were being constructed, thousands of sheet piles, you will not have the same quality. Even where your what we call the distribution, the pie distribution for quality control, even where it is very high, maybe 1 or less, which is very, you will still have quantities of concrete that are not as good as the others that were used for some sheet piles. So logic says that you are getting to a point where somebody should be saying, look, we should just have a health check. It's called the health check, and to see and determine what needs to be done. So that will be my answer to your question. You are absolutely fantastic question. It's a similar problem, similar scenario. And if the concrete has gone beyond its half-life between when it was constructed and now, I think technically we're getting to a situation whereby there should be an inspection across the entire length and an observation made, and based on that, decision should be taken as to what to do. I hope I tried to answer your question, sir.
Yes, you did.
Okay.
So I want us to probably go beyond just this our talk. We've brought out the issue. We've seen it. It's something that is facing us. Okay. I'm sure those sheet piles would have been done because I'm over 50 years of age, and I know I've been saying it since I was a little kid.
No.
So definitely, I'm sure it's over 40 years old or more.
Yeah.
So I would want, maybe through the NSC or through your organization, at least we speak out to the right authorities in charge that
yes.
Going by this, there's a need for us to check this and see what remedials that can be done.
Exactly.
Because if you all just say it doesn't concern me,
Now you know what happens with those ones. The sheet piles are even worse. you know, the dock structure it's a structure in itself. So it has the foundation, it has the deck, it has the not the pile cap now. It has a proper deck where there are buildings, there's a walkway, and then you have the moors that tie to the ship. So for the dock, if there's going to be a failure, you will have load redistribution or you will have local collapse because the failures will not happen all at once. So for the dock, it's even when it's getting to the end of its lifespan, there are mechanisms based on, you know, various formulas that are in the codes. Even as at that time, as old as those codes were, they were fantastic codes, just that we've tightened the analysis now is more rigorous. So if you look at the Eurocode 2 that we use for concrete, the factors of safety have been reduced from 50%. I think it has now, because if you combine dead load and live load factors of safety, it has dropped now. But the analysis you are going to do now is tough. For a simple one span slab, when you want to follow strict Eurocode 2, if you see the lines of analysis you are going to do, even though everything is automated with software and all that, just to make sure that we are very precise. However, for the sheet pile is it's a standard retaining wall, but because it is going very deep, all you are doing is you are resisting earth plus water pressure. But because it's going very deep and it is thick, it can go as deep as possible. However, its own failure mode, when it is going to fail, everything will go at once. Everything will go at once. There is no, because you don't have, where will it redistribute the load to? And the challenge is that once one section goes, all the pressure moves to the other section. So what you are saying is very apt. I'm just trying to put flesh to the importance of what you are saying, that there are structures that will be a lot more sensitive to these kinds of issues. And if we feel they've gotten to the end of design life, it's something we should shed light on and allow the authorities to take a look at it.
Thank you very much. So, Ma, please, let's probably take steps towards advising the appropriate authorities so that at least it will be our only contribution to our collective welfare and safety in Lagos.
Thank you very much, Engineer Balogun. I will just check again. There was a time we went to Marina on industrial visits, on technical tour around the ongoing bus terminal. I know work is going on there, and we were taking around the Marina shore, but I know there are many more of such. So we need to check back on the rehabilitation work at the Marina terminal. Not only, I mean, the Marina in Lagos Island here. There are many marinas around Lagos, so I'll just check that. Thank you. That's to show that there is somebody is looking at it in government, and work is being, money is being disbursed with rehabilitation, but I'll check again. Thank you for raising that. Thank you. Over to you, moderator.
All right, thank you very much, Ma, for that contribution. I'm sure we don't have any more questions on the call. So we'd like to move to the presentation of certificates to our invited guest speaker today. I would like to have the certificates projected, if possible. I would like to invite Engineer Ganiyu Olabi, FNSC, to assist us in the presentation of the certificate to our guest speaker. That will be projected soon. Thank you.
Okay, I'm waiting. I'm waiting for the certificate.
Okay, 1 minute. Let me do it from my end. Can you enable me to present?
I can go ahead if there's no certificate to present now.
No,
There is, sir.
there is. It's just to
Okay.
Engineer, can you enable me or you? Okay, let me send to Engineer Peter.
All right.
Apologies, whilst we're doing that, you can please applaud our speaker for such enlightening session. Thank you very much. Thank you very much. I see our 10th branch chairman, Engineer Bola Akinbudo, FNSC. Thank you very much for joining, sir.
Yeah, good evening, my chairman. Yeah, good evening, my chairman and other members on call. I think I want to appreciate, as a mechanical engineer, all I've learned today. You know, unfortunately, we have a lot of talents in the country, whether they are residents here or the diaspora. But as Engineer Balogun already pointed out, there is lots of opportunity we could have used. But pardon me for one thing, that those still in government, they see you as maybe I can't just understand. I was also in government anyway. But sincerely speaking, these are things which come very, very handy for us to approach and then utilize. But unfortunately, we see people coming as intruders, trying to really intrude into what they should do. It's not that way. Because we've all known exactly what happens in budgeting sessions. And these are opportunities that really do come around and you'll be able to utilize them. However, I think we have to appreciate Engineer Femi Yusuf for what he has done today. As I said, I'm a mechanical engineer, but at least I've taken a lot of notes. And I wish I was back somewhere where I can still go and consult. I would have stolen part of his, his ideas. But at the end of the day, I think the youths really have a lot to learn from such. So on behalf of the Nigerian Society of Engineers, Ikeja branch, I certainly will really expect that you get a physical certificate later on. But let me, on behalf of the chairman and the branch, say what we are presenting you a certificate of honor for really this wonderful presentation. Very short and very, very educative. Once again, let's appreciate you, Engineer Femi Yusuf. And such presentation, I'm sure you are going to repeat more very soon. So on behalf of the branch, let me say a big thank you. And I expect the secretariat to make sure that the certificate gets to you eventually. Thank you very much and God bless.
Thank you. Thank you.
Thank you so very much, sir, for that wonderful.
Did you share this too? I'm not seeing from my end, anyways.
You can send it to him, no problem.
Don't worry, the certificate will be shared with our invited guest speaker. Sorry, the person that was supposed to enable the host is not available. We sincerely apologize for that.
Yeah.
Thank you very much. At this junction,
I'll drop it in your DM, Engineer Yusuf. Thank you.
Thank you, no problem.
At this junction, I would like to invite the branch chairman of NSC Ikeja branch, the 001 of NSC Ikeja branch, to please take the closing remark as we bring this section to a close. Thank you very much, Ma. You have the floor, Ma.
All right, thank you. I think I've spoken a lot today, and I think it's because it's my field that it was quite engaging as well. On behalf of the technical secretary and his team that have made this possible, I want to sincerely thank Engineer Yusuf for bringing himself forward. You know, sometimes we chase people, but he told me that he has 2 papers to present, and when we scheduled the time, he also was able to work with it. I want to sincerely thank you for creating time to put that together. To have gone into the research to put it together and also make us benefit from your wealth of experience. Thank you very much. And as time goes on, I think these are like Engineer Gani Ulabi said that we're going to steal the idea. We're not going to steal it. The whole idea of coming together on this platform is to exchange knowledge, which we have done, and benefit ourselves. So when the need arises, we sure will reach out to you for collaboration and continue to benefit the public from the wealth of experience that you've shared. And on that note, I say thank you to our leaders who have joined. Engineer TK Ibrahim, I see you. Engineer Jagu, thank you very much for joining. And to everyone on the call, thank you very much for always making our sessions worthwhile, both when we meet physically and when we connect virtually as well. It's always very enlightening. To all the executives, I thank you for taking time to be here. And then Engineer Babajide Ajanok, one of our committee chair, I see you as well. Engineer Balogun, thank you for that wonderful. And to all the young age and everyone present on the call, thank you so very much. And see you at our next event. Thank you.
Thank you. Bye.
All right, thank
Yeah,
you so
thank you.
very much for that wonderful remark. Please permit me to invite Engineer Yusuf Abdurazak, the ex-officio of the branch and the immediate past coordinator of the year fund, to give us a vote of thanks as we bring the meeting finally to a close. Thank you. Engineer Yusuf Abdurazak, you have the floor, sir. All right, so we don't waste our time further. We'd like to close this section with our branch item. Please, we'd like the branch item to be projected.
Joe is going to share.
All right, once again, we want to say thank you all for joining us in today's technical section. It's been wonderful experience all the way. We appreciate you sincerely for your time and for your attention to join a section like this. It's been educative, it's been impactful, and we've also learned one or two from this section. And we want to say thank you once again to the invited speaker who has shared with us from his wealth of knowledge. At this junction, I would like to bring this section to a close. On behalf of NSC Ikeja branch, I hereby bring this section to a close. Thank you. Do have a wonderful evening. Thank you so much. Bye.
Thank you, everyone. We can just go and, do meet and greet. Thank you. Mariam Idris, I see you. Thank you. Thank you, everyone. Professor Ajagbe, thank you very much for joining.
Thank you very
We'll
much.
try and share.
Yeah,
Yeah,
all right.
Yes, bye-bye.